Oh yeah, I was standing way back because I mean the guys, they were standing way in the front and they're kind of larger guys, so they crowded me out in the way back. So that's why I look like that. You guys, we've done some problems already. Are there any questions on how to do a particular type of problem? Or the first problem set. What type of problems were? Oh, I guess you know what. One thing last period that I did get to. We'll go to the problems in just a second. So this is all fine and dandy, but we really not talked about what kind of organisms. Yep. Humans. And that's all we really care about, right?
Yeah.
So human genetic is based on this. So human genetic is based on this, and often, okay. So it still follows these rules. Now the very first thing that they introduce is pedigrees. Human pedigrees. What are pedigrees? It's a family tree included with genotype and phenotype, right? It's a genetic. Now, human pedigrees, there are 5 things that you should know, and so you want with descriptions. Oh, I guess 6 things. My bad. You should know 6 pieces of information reading a pedigree. What are those 6 pieces of information? What is a circle?
Girl.
Female. What is a square? Guys, that explains a lot of things. Okay. What are colored shapes? Colored in? They're affected, right? They're affected, or they have the trait. When it says affected, you guys, it does not mean bad thing. For instance, you can do a family pedigree about, like in the book, they have widow's peak or earlobe. That's not a bad thing, right? It's like, but it's just, which part? The earlobes or the having earlobes or having a widow's peak? All right, so it just has a phenotype that you're looking at. Okay, non-colored is unaffected. What is a horizontal line? Marriage, and then a vertical line. Okay, so an offspring, right? It's an offspring of it. Does that make sense? And so what do you want to know? Okay, there's two types of things when we look at. There are dominant traits, and recessive trait. How can you tell if it's a recessive trait or a dominant trait? Okay, somebody said it? Okay, which ones can skip? The recessive one can skip. Okay, it can skip. Therefore, the dominant one will show up in what? Every generation. Okay. Now, oftentimes they look so familiar. The way another thing that I look at is this. So if it's a dominant generation, this can happen somewhere. And then a recessive one, this can happen. So what am I talking about? 2 parents with a disorder or a trait can have a child without, versus 2 parents without can have a child with. Okay, now it's kind of weird because what are the genotypes of the parent in both situations? Okay, both of them are heterozygous, right? So if it's a dominant trait, okay, so what is the genotype of the child in both cases here? Anybody know? It's got to be what? Based on this, it's got to be. Okay, so look at this, you guys. When you look at a situation like this, you can always tell. If this is a dominant disorder, this will be affected. This will be like that. This one will also be like, it's a dominant disorder. That means if you have the big A, you have the disorder. Or the trait, I mean. Okay? This one, little allele, will not have it. Now look at this. A recessive, what would happen if it's a recessive, let's say sickle cell? What would you do? You would not color it in, right? But what if the child is that? So look what happens, you guys. It's the opposite. It's the opposite. So that's what I mean by two parents with can have a child without, and two parents without the trait can have a child with. So when you look on page, what do you call it? Look at 265. 265. Say what? Okay, the reason why you guys, okay, look at the both of these traits. Okay, one is dominant, one is recessive. Look, so if you look at the recessive one, if you didn't have the information on the left side, it looks like the trait. If you didn't have the information on the left side on the recessive one, so we're looking at the earlobe one, you guys. If you covered up the left side except for that one parent in the middle, it happens in every generation, right? So you look at every generation has somebody with the trait, right? So sometimes it's kind of hard to see it. But look at what happens. Each of these have a situation where two parents without have a child, at least one child with. So you know that it's a recessive trait. On the other side, when you're looking through it, you find a situation where two parents with have a child without. So that's how I kind of look at it too. So if you will look on page, let's look at one of the problems you have to do tonight, number 14. What kind of a trait is that? You can look at it, you can tell, you should be able to tell what kind of trait that is by finding a situation. What situation are we going to look, what individuals do we look at to figure out what kind of trait this is?
Anne and Michael.
Anne and Michael, right? Anne and Michael without have a child, Carla with. So what kind of trait is it? It's a recessive trait. You can tell right away, right? Boom, it's a recessive trait. Okay? All right. Everybody understand? Okay, so now we go back. Look at that, you guys. I said we need. Where's the? You should cut up the little red and gold one, and put it.
I'm just a little tired from doing that.
What?
It's exhausting. I thought you were tall.
Okay, how authentic is that, Toby?
What?
How authentic is that?
Great.
Do you feel included? It's an inclusive classroom here. We're working on that. I don't know how to represent that well.
I give them 7 and they're different colors.
What? What is it?
It's similar to that, but there are only 7 of them and they're specific.
Oh,
colors.
that's for Kwanzaa
7?
or something.
Yeah, so
Yeah, but all holidays matter.
I know, but how? So actually, it looks like that.
no, it's like a bar with 7 candlesticks on it.
Sweet. Okay, now we just got to get the color. Well, we'll do that with construction paper
Ah.
or post-it notes.
Oh my god, it's
Huh? Yeah, that'd be kind of cool. But then that'd be kind of hard to get. All right. You know what? You guys realize we're never gonna take these decorations down, right?
yeah.
Just too much work. Hey, is this kind of like some of the houses around my neighborhood? It's like year-round Christmas celebration. It's like, you're really not gonna take that down? Oh, we had a house in our neighborhood that still has their Halloween decorations up. I'm like, okay, dude, I'll give you until Thanksgiving, but past Thanksgiving, that's a little much, okay?
That one.
No, I don't know, like lights and then just like blow up things that are not inflated. They just have them just taking it down. Yeah, they just have them sitting. Okay, now I'm gonna ask you: are there any particular types of probability problems that, or you want to know the answer to see if you did it correct, because then Tobis will give you the answer. Tobis, how about you answer that, Tobis?
You're trusting that
In Tobis, we trust.
Wait, when did you become our god?
No.
I've always been.
What?
Yeah,
The great thing about teaching this class is that I know that there will at least always be minimally one person who knows exactly what the answer is, so I don't have to do the work. Okay, Vanessa, what number or what type of problem are we talking about? Okay. Well, what was the probability thing? The probability of what?
I don't know if we're like doing the phenotype of disease.
Oh, yeah, but what was the question? All the what? So that's phenotype, all dominant traits. Okay, so all dominant trait for A. Okay, so I think B and C were forced, right? So that was 1, right? 100%. So what is A for? How about A and D? What are the chances of it? 3/4. So what is the probability of multiplying the 3/4 times 1 times 1 times 3/4? Yeah. So the probability of having an offspring with all dominant traits in that particular cross was 9/16. Even if you did, watch this. If you calculate it separately and you add them, the answer will be the same. Right here, I'm gonna tell you what I'm talking about. So, so you're calculating big A, big B, big. Okay, it has to be big C, or something like that. I don't know. Well, it doesn't matter, right? And then this big D, little d, right? If you did all these combinations and you did big A, and big D, little d, or let's see, big A, little a, big D, or big A, little a. I'm sorry. Which one was it? Okay. Wait. I erased the problem, so I forgot what the cross was. But if you calculated all the individual ones like you did, yeah, and you added them up, it will be the same. Right? And you can try it if you want, but I mean, like, if you calculate it for only big A, because what happens is this. Let's just do this real quick. What is the probability of the big A, and the big D one? So what would you calculate this at? Because it would still be 1, right? Right? This version of it, this version of the phenotype, no, this one would be what? Big A. It'd be 1/4, right? And then big D would be 1/4. So this will be 1/16 of that 9/16 that you're going to add up. Then you calculate what? Big A, little a, big D. Okay. So this would be what? 1/2 times 1/4, and then what would that be? 1/8 or 2/16. Let's say we did the 2/16. If you keep on doing that in all the possible things, it'll still come out 9/16. Does that make sense? Okay. Any other ones that you want to check your answer on? That's it? You feel good? Too scared to ask. Come on. Tobis will only look at you with disgust and then give you the answer. Can't be that bad.
And I do that anyway.
None? Chris, you feel good?
Huh?
Come on. What's that, Sonny? All right, you guys have a good day.